Before we can move on to the third way to produce precipitation by frontal means, I've got two small topics that I want to talk about. So this is lecture number 4, cloud classification, and then we'll have a lecture 5 on air masses before we get to frontal precip. So I want to talk about how clouds are classified, and clouds are classified by two ways. By the shape or the form of them. And clouds basically have two shapes. It's either blanket-like, and when they're like flat or layered, you always use the word strato. Strato in Latin, stratus means layered or blanket-like. And so when you've got layered or blanket-like clouds, that's when the atmosphere is gently and broadly lifting the air and cooling it. And this is by fronts. This is mainly by warm fronts, as we'll see. And so you wind up with broad regional uplift. Gentle uplift creates these layered clouds. Now, the ones we've kind of been talking about already are the puffy cumulus type clouds, the cotton balls. And so they're cumuloform. And this is by, rapid localized uplift by thermals rising and cooling adiabatically. And so when you see that shape, you always add the word cumulo. And then the other way that you classify clouds by a height of development in the troposphere, where they develop. So we'll kind of put those two things together. So you can see we're going to be at the ground, looking at this figure, looking at the ground, and we're going to be moving up 1 mile, 2 miles, 4 miles, and then about 8 miles to the top of the troposphere. And so we're going to start with the high cloud family. Let's take a look at this figure here. All right. So clouds that occur at the highest altitudes, between about 4 and 8 or 9 miles up, way on up there, it's called the high cloud family. And what you need to know are the high clouds, the high cloud family, are known as cirrus clouds. Now, because it's so cold up there, 60 or 80 below zero, all the clouds are made up of ice crystals. They're all frozen. And so the classic are cirrus clouds. They're kind of thin, wispy clouds, and they're kind of neat to see because these wisps often kind of show the direction of the upper level winds or the jet stream aloft. But sometimes the ice crystals can be layered very high on up, and when they're layered, you always add the layered root word stratus. So they're high up cirro, and then you add stratus for layered. Sometimes there's a little verticality at high altitudes, and again, there's still ice crystals, but you'll wind up with little kind of small cumulus puffy clouds, usually lined up geometrically by upper level winds, but they're usually kind of small because when you're very, very high up, at this altitude, you're really high, far away from where the ultimate moisture to make clouds is, the ocean. And so the clouds invariably are going to be thin. There's not a lot of moisture in here. So, of course, you'll never get any precipitation from a cirrus cloud. The middle cloud family, as we call them, are alto, and alto in Latin means middle. So we're talking about 2 to about 4 miles up in middle levels in the troposphere. And alto clouds come in two basic shapes. If they're layered or blanket-like, but kind of high up, indicating usually approaching bad weather. Usually, over the next day or so, the stratus clouds will start to get lower and lower, indicating a front moving in. But right here, the front is still probably a few days away or a day away, and so they're middle levels, kind of high up stratus. And then sometimes taking on a globular shape, alto cumulus, and usually the alto cumulus are there's more moisture at middle levels compared to the cirro levels. And so usually the alto cumulus are, again, kind of high up there. They're not really close to the ground like normal cumulus, but they're usually bigger, all right? And again, kind of usually in a geometric pattern, indicating, the winds kind of lining things up. Then the low cloud family, and this is stratus. And we're talking about low. I mean, within maybe 2,000 feet, 1,000, 2,000, 3,000 feet. So there really is a big difference, between the stratus, and then, the middle and upper. I mean, you can really see the difference. And so the stratus cloud family are basically the low clouds. Stratus means layered, so the classic layered clouds, very, very low, 1,000 or 2,000 feet. Now, these clouds produce rain. The alto clouds don't. I mean, they're still too far away from the moisture source. And so being within just a couple thousand feet of the ocean, these will be thick clouds and will have a lot of water vapor in them being so close. So you always add the root word nimbo when you're getting rain from the stratus clouds. Right? Usually indicating maybe the weather system moving away, and you start to see breaks in the stratus clouds. You start to see little pieces of blue sky here and there. And so usually the stratus clouds will grade into stratocumulus, indicating clearing conditions. And then again, they're going to be low clouds, but still pretty thick. I mean, you still have a lot of kind of stratus feeling, but just little spots of blue indicating clearing conditions. And then there are the fourth cloud family, as we say, are clouds that develop vertically in the troposphere. And so they'll start within a couple thousand feet, and then as cumulus clouds. But if the conditions are unstable, we can actually create, clouds with vertical development, throughout the entire troposphere, creating our second rain cloud, cumulonimbus clouds. So of all the clouds, there really are only two types that do produce rain, the nimbostratus and, of course, the violent weather cloud, the cumulonimbus cloud. Let me just show you a few pictures of some. I mean, here's the classic cirrus, thin wisps, very, very, very high on up, made entirely of ice crystals. And it's kind of neat to see the upper level winds being revealed by the shape of the wisps. Cirrostratus are kind of interesting. It's a very, very thin blanket of ice crystals, very, very high on up. And it gives the clouds, the ice crystals are so far on up, and they're kind of a dense mass, and so it kind of gives like a veil or a milky look to the sky. And we see cirrostratus, pretty commonly in Louisiana. A lot of times after maybe a cold front comes through, and it isn't really perfectly clear just yet. There's some lingering upper level moisture, and so this milky look to the sky is a common feature that you can see around here. Cirrostratus, cirrocumulus. I mean, are these little puff balls, but they're very, very high on up. I mean, again, you got to start. You get kind of a feel when you look at the sky. When a cloud is 8 or 9 miles up. All right, let's move to the middle cloud family, altostratus. And actually, I've got a mountain here. This is Mount Shasta, which is 14,000 feet in northern California. It's a volcano. And so 14,000 feet, that's almost 3 miles up. And so, luckily, I've got kind of a guide to give me an indicator as to how high up 3 or 4 miles is. And of course, that would fall into the alto category. And so we've got a blanket-like layer, indicating, a weather system moving in. So that's altostratus. Altocumulus are usually, like I said, they're usually, bigger than altocirrus, and because they're closer to the source of moisture. And again, you just got to kind of get a feel for what is about 3 or 4 miles up versus 8 or 9 miles up. Here's the classic stratus. Right? You can see that this blanket-like cloud, is really forming within probably about 2,000 feet. Right, from the Earth's surface. So stratus are really easy to kind of pick out. Here's stratocumulus, like I was saying. The stratus clouds are kind of moving away. The weather system is moving away. And it's when you start to see little patches of blue in the stratus clouds. The clouds are breaking up, as we say. And so this is a nice example of stratocumulus, indicating, clearing conditions. All right. So this is one of the clouds, nimbostratus, that is a rain producer, being so close to the source of moisture, the ocean, that you can have a fair amount of water vapor and get rain from the stratus cloud. So you always add the word nimbo when you're getting rain from a cloud. And finally, the low cloud family that can grow vertically. The clouds with vertical development. Here's an example of clear weather cumulus clouds. You can see the dew point. They're all forming at the same altitude, but we're still dominated by high pressure here, but sometimes there's enough moisture, and so the clouds are rising and staying warmer than the surrounding air. But once you get to a certain point at the cloud top, you wind up with that bubble of air becoming colder than the surrounding air, and so they can't grow vertically. So that's what's usually happening when you see, clear weather cumulus. You've got a little bit of verticality, but the air is kind of stable, and you wind up with the bubble of air, getting colder, so they can't really rise to tremendous heights. But in this case, here's just a nice example of our second, rain producing cloud, the cumulonimbus. And this is a nice example of a single anvil top right here with the upper level winds carrying the cloud downwind. You see many fine examples of cumulonimbus clouds in South Louisiana, in summertime, with convection. And then, as we're going to see, you see them a lot of times associated with cold fronts coming through in wintertime, but that'll be in another lecture. And you can see here's the warm updrafts on this side of the cloud, and then the cold downdrafts, and that's where you get the rain in the downdraft side of the cloud. End lecture.